Let's take a look at these two tables that I have set up here before we talk about types of errors, because I think these are going to help us to understand the types before we even look at a formal definition. I think this does a good job of illustrating the two types, especially this first table up here. Let me just make this bigger because I think it's easier to relate to rather than, the statistical test because we're not really familiar with that yet. But the possible outcomes of a trial, I think we have a little bit more familiarity with that. So there's a couple of ways that a trial could go down, right? A person could be found guilty or not guilty. But just because the jury comes in and says, okay, I find this person not guilty, doesn't mean that they're necessarily not guilty, right? They could have made a mistake. Or what if the jury comes back and says, we find the person guilty, but the person really wasn't guilty? So the whole point of conducting a trial is to come up with the correct conclusion about the person that's on trial, but sometimes, unfortunately, mistakes are made and they have some heavy consequences, right? So think about one possible mistake or wrong decision that could be made in a trial. A not guilty person could be found guilty. An innocent person can be found guilty. That could be awful, right? Because a person that really is innocent potentially could be sent to prison for the rest of their life and they didn't do it, right? That's pretty awful. That's ruining somebody's life right there. Or the other wrong decision could be finding a guilty person not guilty and they're set free, they're off the hook. But that could be very dangerous, right, to the community because they're back out in society, a potentially dangerous person, and they could commit, crimes that are just as bad or even worse. So it's like, what's worse, putting an innocent person in prison forever, potentially, or taking a dangerous, guilty person and letting them back on the streets? Both, in their own way, are terrible mistakes. And we want to try to minimize the potential, right, or the risk of making those decisions in the first place. But sometimes, unfortunately, it happens. So these two wrong decisions in statistics have a particular name, and we'll get there. But let's just look at it in terms of possible outcomes of a trial because I think it's easier to understand. So there's always truth, right? The truth of the matter is the person is either going to be not guilty or guilty, right? But then there's the jury's verdict. They're going to come back and make a decision, guilty or not guilty. So let's go through this table. So what if the person in reality is not guilty, but the jury comes back and says, we find you guilty? That's a wrong decision, right? They made the wrong decision. What if the truth of the matter is the person is not guilty and the jury comes back and says not guilty? Well, that matches, right? That's a correct decision. You want to find a not guilty person not guilty. What if in reality the person is guilty in real life and the jury comes back and says guilty? The match was made. It's correct, right? Guilty person found guilty, correct decision. But what if in reality the person is guilty and the jury comes back and says not guilty? That doesn't match, right? Wrong decision. So there's two possible wrong decisions that can be made, right? And there's two possible correct decisions. So in statistics, so let's look at this from a statistical standpoint in terms of the null and the alternative hypothesis. So again, this top row is going to represent reality, and then this column here is going to represent the conclusion that was made. So what if in reality, the null hypothesis is true, but the conclusion is to reject it? So if something is true, do you want to reject it, get rid of it? No, right? If something's true, you want to keep it. You don't want to reject it. So that would be considered an error, a mistake. And in statistics, we call this a type 1 error. So the definition of a type 1 error, so what happens when we make a type 1 error is that we reject the null hypothesis when it was really true, right? You don't want to reject the null if it's true. That's a mistake. What if the null is true and we fail to reject the null, meaning we don't reject it? That's a correct decision, right? Because if something is true, if the null is true, you don't want to reject it. We want to keep it. So that's a correct decision. What if the null is false and we reject the null? So if something is false, you don't want it, right? You don't want to keep something that's false. You want to get rid of it. We call it rejecting. So that's a correct decision. So if the null is false and we reject the null, we did the right thing. But what if the null is false, but we don't reject it? We fail to reject the null. So the null is false and we're going to fail to reject it, meaning we're going to keep it. So we're keeping something that's a false statement. That's an error, right? That's a mistake. We call that in statistics a type 2 error. So a type 2 error is when we fail to reject the null hypothesis when it's false. So that's the difference between a type 1 and a type 2 error. Now, when we go through a hypothesis test, our goal is going to be to minimize making these types of errors, right? We want to do the best that we can to not make a type 1 or a type 2 error. And I'll talk about how we're going to do that using probability. But right now, all I want to do is just practice identifying the difference between a type 1 and a type 2 error. So this is example 5. So example 5, type 1 and type 2 errors, we're going to practice. Suppose the bride-to-be is going to test the following hypotheses. So the null is that the mean cost of a Long Island wedding is $40,000. And let's just write that using symbols. Sometimes it's just easier, right? So another way to write this is that the mean cost of a wedding is equal to $40,000. And then let's just write the alternative. The mean cost of a Long Island wedding is greater than 40,000. So we could write mu is greater than 40,000. So that's how we would write it in symbols rather than words. So these are multiple choice. Number 1 says, which of the following represents a type 1 error? So I think the easier way to do this, so it's not confusing, is don't look at the choices. Let's not look at this. I'm ignoring this for a minute. Let's use the definition of a type 1 and a type 2 error to try to figure this out on our own. So a type 1 error, remember, is when we reject the null hypothesis when it's true. So what we'd be doing here, so if we made a type 1 error, we would reject the null hypothesis that the mean cost of a wedding is 40,000 when it was really the true mean cost, right? Because you're rejecting the null when it's really true. So we would reject the hypothesis that the mean cost is equal to 40,000 when it's true, when it's the true mean cost. So that would be rejecting the null when it's true. So now let's go look at the choices and, pick the correct one. Which one says that the bride-to-be would reject the hypothesis that the mean is equal to 40,000 when it's really the true mean cost? And that's A. So 2, which of the following is a type 2 error? So a type 2 error is the opposite. So a type 2 error is when we fail to reject the null hypothesis when it's false. So again, I'm not even going to look at the multiple choice questions. And so what we would do is we would fail to reject the null that the mean is equal to 40,000 when that's false, meaning when the true mean cost is more than 40,000. So we would fail to reject the null that the mean is equal to 40,000 because that's the null when the true mean cost really is greater than 40,000 because the null is false, but we're failing to reject it. So what choice is that? So when we fail to reject the hypothesis that the mean cost is 40,000 when the true mean cost is really more than 40,000. So that's going to be C. And then question 3 says, which of the following is considered a correct decision? Now there's 2 ways to make a correct decision, remember. That if the null is true, we don't reject it. And if the null is false, we reject it, right? So let's just kind of read through these and see which one is the true statement, right? Because there could be 2. So rather than writing both of them down, let's just do process of elimination. So A says the bride-to-be rejects the hypothesis that the mean price is 40,000 when it's the true mean cost. That's not a correct decision, right? Because you don't want to reject something that's true. So that's not a correct decision. B, the bride-to-be rejects the hypothesis that the mean cost is 40,000 when the true mean cost is more than 40,000. That's correct because she's rejecting the hypothesis that mu is equal to 40,000 when the true cost is more than 40,000. So we'd be going with the alternative. So that would be a correct decision. And then if you read C, C is not a correct decision. It's a type 2 error. Okay, so that was our first example, differentiating between a type 1 and a type 2 error. And let's do one more. So example 6 says, suppose a real estate broker is going to test the following hypotheses. So the null is that the mean price of a single family home is $243,763. So I'm just going to write this using symbol notation, just easier sometimes. So mu is equal to 243,763. And then the alternative is that the mean price of a single family home, so that mu is less than 243,763. Okay. So 4 says, which of the following is a type 1 error? So remember, we make a type 1 error when we reject the null hypothesis when it was really the truth. So we'd be rejecting the null that the mean price is equal to 243,763 when it really is the true mean cost. And that's B. So B is a type 1 error. And then 5, which of the following is a type 2 error? Type 2 is the opposite. So it's when we fail to reject the null when it's really false. So we'd be failing to reject the hypothesis that the mean price or that mu is equal to 243,763 when the true price is really less than 243,763 because it's, the null is false, but we're failing to reject it. So that's going to be choice A. So choice A is the example of the type 2 error in this situation. So before we wrap up this lesson, let's talk about what a type 1 and a type 2 error would be if my null and my alternative hypotheses were innocence and guilt, just to get one more practice question in here regarding type 1 and type 2 errors. Okay, so suppose the null is that the person is innocent and the alternative is that the person is guilty. So what would a type 1 error be? So that would be if we were to reject the null when it's true. So rejecting the null would be going against innocence and going with guilt when the null was really true, when the person was really innocent, right? So the jury finds the person guilty when he or she is really innocent. So that would be an example of a type 1 error if this was my null and my alternative hypothesis. And then let's do type 2 error. So a type 2 error is the opposite. So a type 2 error would be if we fail to reject the null when it's false. So we're not going to reject the null. So we're going to say that the person is innocent, but that's really false because the person is really guilty. So the jury finds the person innocent when they were really guilty. So when he or she is really guilty. Okay. So just another example of the difference between a type 1 and a type 2 error. And you'll see how we're going to try to minimize the risk of making these types of errors when we start conducting a hypothesis test.